So guys, now we want to look at the data which we have here. This is the data for US. Remember, we already build out this data set, and then we had our parameters. Yeah, that are parameters which we can use it, but we must select the set parameters of concern which we are interested to evaluate. And so, without wasting much of our time, remember this is the ID, the site number, okay? And this is the data for Maryland, as we explained. And don't forget that we are dealing with spring water. And this is another aspect of our analysis. And the last aspect we checked for UK was borehole and groundwater source. So this is a spring water in Maryland with this particular site number identified under United States. Okay, so what I did was I just had to copy all of this, get, and then I had to copy like this and then paste in the new sheet. And this was it. And then I had to delete some certain number of rows. For example, uh, these dates I have to delete, and delete this and delete this because we don't need. And then at the end of the day, we just need to choose one particular year. For example, because we had three different input data for the year 2000. So we had the test was conducted, like I said, on the third month of 14, the sixth month, and then on the 8th. So we are going to choose on the 8th month, okay, data which was collected, water quality test which was done on the 8th month for that particular spring in US. So this is what we're going to be using, and we will need a certain parameters which we want to choose. So after doing the copy and paste, and then deleting the other cells or other rows which are not important, and we will have to be able to select our parameter. So, and remember, this is the ID, okay, for this particular parameter. So it's called the parameter ID, okay. So what are we going to get now is that we have to select P00010. It's the temperature, okay. And we have this dissolved oxygen. So I've already selected this, so we should not waste time. So if you want to check back, you can get to the data which I'm going to provide for you guys. And then you can follow up with the ID to make sure you also select the same. So this is it, fecal coliform. So I have already identified that, and E. coli, I have already identified that. So this is the IG, and this is E. coli, see? And fecal streptococci, okay. So what we need to do next is to be able to delete what we actually uh, don't want, okay. So all of these, we have to delete it because we want to produce now our analysis. And for this exercise, we're just going to go straight to correlation analysis, and then we build our graph. Then we are able to discuss and interpret what is going on in this particular spring in the US, okay? So we just have to delete this, delete, and then delete this. So delete this. And then we delete this. Okay, so now we have this data and this data. So like I said, we just need that of the 8th one. I put here too. So that we are going to create something else here. So I'm going to delete this. We don't need this. But for other analysis, you might choose for this particular month on the 6th month, and you can do your other analysis. You have the data. So delete. So this is what we have now. And then we want to copy. No, first we have to insert. So we bring this here and then we copy this, copy, and then paste. And then we have to delete this. So now we have results. Results of spring. Maryland. Okay. And then here we have parameters, and then here we have parameter ID. Okay. And then we can go ahead and then we go to home and then we choose no field, as well as we can choose like this. Sorry, need this like this. Okay, no field. Okay, and then we can as well select this and make it bold. And then we can choose here US water standard, and then we have here WHO. Okay. So like we said, for temperature, we want to choose 22 and 22, and then dissolved oxygen 5, 5, and then pH, we're going to choose 9.5. No, for WHO, it's supposed to be 8.5. Okay. 8.5, and then 9.5. Yeah. And then fecal coliform 0, 0, 0, 0, 0, 0. And then here we have 45, and then we have 50. So this is how our analysis looks like, our data is going to look like. And so we are ready to start our data analysis using correlation analysis. And we'll be able to understand what is going on before building our graph, and then we'll make final conclusions. It's just going to be very straightforward. Correlation, click. So it is selected, click OK, and then you want to make sure you select what you want. So we want to correlate the result of the spring in the Maryland with that of the drinking water standards of US, and then that of guidelines of WHO. So we click first row, and then where we want it to be. So we can click here, and then we select, we want this analysis to appear here. So we click OK. And there we have this. This is now, this is really not the same like we saw in UK. And so it calls for a good concern for us to be able to understand what we are having. So with this analysis, it gives us a clear picture of the level of risks we have in this water source in US, Maryland. Now, if you see the correlation, this spring, normally, like we always say, correlation analysis between 1 to -1. So if you see this particular correlation where we have a minus and a minus, it means that there is something wrong somewhere, which means that there is totally no correlation at all, which means there are some particular set values of our measured parameters in the water source, which is absolutely out of place, like totally out of place. It gives us that the data is really not in collaboration with with the other. There's no fit, as I can say. So which tells us that automatically we can know that there's serious danger in this particular water source compared to that of uh, of um, of UK. Okay, so this is what we should understand. And what if I want to say, let's try to do something? Because if we see this negative correlation comes in because we have a very high values of detected fecal contamination, E. coli, streptococci, and fecal coliform. Okay, so and we have here 0, 0, 0, 0, 0. This is where the problem is. And so we must be able to understand this analysis, the way we must produce our interpretations. So how should we get along to understand what is going on? So for example, if we say maybe if we can say that US decided that okay, they needed the fecal coliform standard to be at maybe 300, and then this should be at 300 also, and then they want E. coli to be at maybe 200, and then WHO maybe 250, and then we have something like 800, and then something like 1000. Or let me say 850. Okay. Now let's try to run the correlation analysis again and see what happens to the correlation between that. And you see that this negative will turn to positive. And you understand that it will be closer to 1, which means that it's always is rather close to the standard levels or standard values which we have. But still yet, it is not safe. Like I said in the other exercise we did and analyze that if it's too close to 1, it means that our values are really very close to the red line. You understand? Which means that these particular values should not even get closer to the standard values which have been set, or the marks which have been set, that our test values should not be over these marks. Okay, so if we check correlation and then we want to see, okay, we just click okay because everything has been said, and you have this thing, correlation output range will override existing data. So okay, we click okay, and look at what happens. You see, so we now have here 0 0.9, 0 0.9. There is no negative. So, and still we have here almost similar values of very closely tied and to the standard of US and that of WHO. You see, it's closely tied, which also means that this water source, it's not really good. Yeah, at one point, it's not really good to really say, because it's really closer to the limited or acceptable range. Okay, acceptable range of values. So that is why we must really understand about how this correlation works. So if we are going to be having just minus, and from that we have to understand that it's the highest risk ever when you start seeing minus correlation and between your measured value from the lab or the test you conducted with that of the standard of your country, or maybe and that of the standard of guidelines of US. then there is a problem. Okay, so there's a problem, and we're going to have that. So that is that. And so we are back to negative. So I have 0.3 minus 0.3 minus 0.4. So this is how this analysis works. And if we want to do our graph like we did with the other one, in UK, we just need to highlight like that. And then we just go to the line, and then I would like to choose this so we can see clearly. And it's easy to make interpretations with this. So with this, you can see what we have here is very clear. At the point of E. coli fecal coliform, you see, and this is our result of spring in Maryland. And we have here, look at the value. You see, it's above the set limits. Yeah, the set limits, the limits of WHO and US water standards, okay? So this is just what we should understand. This is E. coli, you see, it's above. This is the limit here. This is it, right up, you see, above. Already, we know this water source is really not as good as compared to that of UK. So this spring is highly and totally contaminated, and therefore it should be prohibited with an immediate effect. It might be a pollution coming from, I don't know, a sewage around the community area. This is what we should understand about this type of pollution mechanism. So with such high values, we should be thinking in our analysis, because we're trying to interpret what we have now, that this kind of high levels might be due to either leakages from septic systems or community sewage treatment treatment systems around where we have this particular spring, which is the site. Okay, so we should understand that in our own interpretation, this community find around this place must be very, very alert, and also be able to report such pollution which is around their community or environment. And then we should see how they can be able to treat or stop using this water source. I don't know for what purpose. Even if you have to use it for your livestock, it is also in a serious threat to livestock. Okay, so this is a good example of a highly contaminated water source we have seen just from our analysis, and also we compared both sides. So if you want to say both water sources in UK and US are all contaminated, and they all need follow-up, okay? But if we want to talk on the basis of how the risks of these communities can be evaluated, then we can say intervention needs to be very, very, very quick to visit US and to see how people can be rescued in terms of maybe an outbreak of cholera cases or whatsoever. So this is how we can analyze, and that is it. And so I think we can now say it's okay to give reports to build whatever I want to build, and from both the two data sets which we had, and we are able to come to a conclusion and understanding of our data, and then we can have some discussion and some interpretations. Okay.